Okay, well, I went out and got a camera, but it seems I should have went out and also got a stand. So, this is question 1 from chapter 1. I'm going to try my best to hold the camera steady. It's probably already a little bit jarring. So, the question asks, explain in words or diagrams why u cross v is equal to negative v cross u, and that w dot u is equal to w dot v, which is equal to 0, where w is equal to u cross v. So, starting at the first part, if we have an arbitrary vector u and an arbitrary vector v, which I've drawn here in black, and we want to find their cross product, we can then make a parallelogram and then assign that parallelogram's area as the magnitude of w. So, as you can see here, v and u, with their corresponding uh, uh, relevant vectors v prime and u prime, make this nice parallelogram with this area. Then you see over here negative v and u make the exact same shape or exact same area with their corresponding u prime and negative v prime. So since these two areas are the same, we know at least that the magnitude of w is also going to be the same in both cases. Now we just got to make sure the direction of w is the same, right? So w right here, as I've drawn, is on a 2D surface, but in reality is probably coming out at you from the paper's plane, right? So to figure out if it's going into the paper or coming out of the paper, we need to figure out which way our vectors are aligned. So with u cross v right here, we go from vector u to vector v. You see it's going in a that's counterclockwise direction. With vector negative v and vector u over here, you can see once again traveling from the tip of vector v to the tip of vector u. We also still have this counterclockwise direction. So we know that w is also, in both cases, the same direction. So since these both produce the same vector w as their equivalent cross product vector, I guess is can't think of a better word for it. We know that w equal w, thus u cross v equals negative v cross u. They make the same area. Okay, then for the next one, we have w dot u and w dot v is equal to 0. Well, no, w dot u equals w dot v, which equals 0. So they both equal 0. This one's a little simpler. So for my drawing here, you think of the dot product like a projection of one vector onto another, then you can see that u and v, since w is actually coming out of paper here, they have no components that align with w's axis. So there is no projection, and thus the answer is 0 if you try to do that dot product. Same thing over here. It's coming straight out of the page. No component, no part of v or u ever ever can be projected onto w. So once again, it's still 0. And yeah, I think that settles it for question 1. Hope that's an adequate answer. And if you like this video, click like and subscribe and leave a comment. No, I'm just kidding.